let us discuss about searching a linked list. So as you know, linked list, it's basically a data structure which consists of several nodes, and each node consists of information and the link details. So the linked list consists of several nodes as shown here. So there are many nodes are there, and each node has some information. The information may be a number or anything else. So for an example, let us say some number, I use it here. So 8 and 4, I use it like this. Then I can do what I can do. I can search for a particular number or a particular detail from the linked list. How do we do it? Let me say I want to find out where a number 8 is stored in a linked list. Okay, or whether 8 is stored in a linked list. That is all. Like that also we can do. So what my algorithm has to do, the search algorithm, it has to search, it has to check with the first node, and then it has to check with the second node. As it checks with the second node, it compares with the number of my interest. If it is equal to 8, then it will return the location of the node. So let us say this is 0, this is 1, and this is 2. Then it will say the 8 is loaded onto the location 1, or we can say node 1. Node 1. So that is what the searching algorithm will do. And also the searching can be done for two types of linked list. Singly linked list only particularly I'm talking about. So you can have a linked list which is unsorted and also sorted. Unsorted means you will have a random numbers as shown here. Sorted means the linked list itself would be sorted. So by following the link, you will be able to see the given details are sorted in a particular order. Okay, so in this detail, what we are going to study here is, we are going to study about how to search an unsorted linked list. How to search an unsorted linked list. So this searching operation involves three major operations, major functions also. First one is called traversing. Traversing means we are accessing the nodes of the linked list. Accessing the nodes of the linked list. Comparing is, the comparison is done with an item. Item means what? The user input, what the user value, for what value the user need to do a search. So item, it compares with an item. Then also it updates the pointer. The pointer, in our context, we always use a variable called PTR. So by keep on updating the PTR, we'll be able to do the searching operation. Next. And as we do involving in searching, we have to do two important tests. The first test is whether we have reached the end of the list. End of the list. What do you mean end of the list? So if we have a linked list which consists of several nodes, it is not going to be continuous. At one point, it's going to terminate. Got it? So if this is the linked list, and this node will be the terminal node. Got it? So after this, you should not do any operation. So that is what we have to search for. Whether as we search, have we reached the end of the list? Got it? So we search for the end of the list either with the help of the null in the algorithm, or in theory we use 0, or in practice by using -1. So either we use null or 0 or -1 to represent the end of the list. So by with this, we check it out whether we have reached the end of the list. Next, as we do the traversing, as we compare, also we need to check whether we have reached the item. Once you reach the item, you need not to continue further. Okay, so whether we have reached the item. If you reach the item, then your algorithm can return the corresponding location. Okay. So these are the two important tests that has to be performed. Okay. Now coming to this algorithm. Algorithm is called as search, and info is basically the information in the linked list. Link is a linear array, and start is a starting pointer, the pointer that holds the start no address of the starting node. Item is the user input. User gives the input. Then what you have is a location. This is going to be the output of this algorithm. When the information and items are matched, then it will return what location you have a data. Maybe a node or maybe a node address, somewhere it's going to give us the information. Okay. Now, so to start the work, first what we have to do was we initialize our PTR. PTR is the pointer that holds the address of a node. And this PTR is initialized with the start. What is start? Start is again a pointer that points to the starting node of a list. So it has the address of the starting node of a list. So that will be given to the PTR. Okay. And next, what do we do? So once PTR is ready to point, that means it's pointing to a particular node. So next, what we have to do is we have to check whether information in the node that's being pointed by the PTR is equal to item. Is equal to item, then what? Then work is done. Then we can say the PTR is the location where the required item is found. Location required data is found. Required item is found here. Okay. So we can return this location as an output from this algorithm. That's one thing. Then next, what we have to do, the next information is by chance, if the item is not equal to the info of PTR. Okay. So that is when else we update the PTR to point to the next node in the link list. So how? By updating the PTR with the link of PTR. Link of PTR. When you have a node linked list, the node in the linked list, this is information part. And what is this? This is the link part, link address. So this address will be pointing to the next node in the linked list. So PTR is now updated with this particular address. Okay, so that means now we have completed one node and now we are moving to the next node. Set PTR is equal to link of PTR. After that, what you have to do? Okay, so then we updated the PTR. After updating the PTR, then we have to check for item in the PTR. So now there seems to be a repeating operation. So we will put entire thing in a while loop. We'll put the entire thing in a while loop, and we continually execute this until PTR is equal to null. PTR is equal to null means what? End of the list. PTR is equal to null means end of the list. Okay. So until we reach the end of the list, we update the PTR and check for the item. And if the item is matching, then we'll see the location of the PTR. See, somewhere it must have got the information. If this information is not found, then we say that location is not found, so it's a null. So that particular item is not available in the linked list. That's the conclusion we are going to draw. Search is unsuccessful. So now you see that either from this part we return our location, or from here we return our location. If the data is available, the PTR will be the LOC, or if the data is not available, then null will be the LOC. Finally, we can exit from the program. Okay. Now, Let us think about linked list, this linked list. Okay. So this linked list basically it contains many details. It has the list and also the link details. List is having the informations. Link is having the address detail. Link is having the address detail. Okay, fine. So now let us see how to implement this and also how to do the searching operation. So let us consider this to be a implementation of the linked list where you have a link and also the list details. So this we already discussed that we can check out with the implementation of the linked list details. So in a list of 0, we have 22. Similarly, list of 13, we'll be having 15. Like that, link is also updated here. And now here we used one function called a search, which is a direct translation of an algorithm. So whatever we discuss in algorithm, now in the computable format, we have search, we have implemented, and that we will discuss shortly. Okay. Yes, now what is this? The start is initialized with the 11. So node 11 is the starting point. Node 11 is the starting point. So we have some information here. Okay. But we do not know what information user will search for. So we should ready for any information. Okay. So what do? We initialize the PTR with the start. So PTR also will be pointing to the starting node. Okay. So first what we'll do, we'll just print using this setup, this loop. We will print the list on the screen. That is, as long as PTR is not equal to -1, we will get the information and we'll display it on the screen. That is for the only for our convenient. Next, what we do, we take the item from the user, and then in order to search it, we call the search algorithm. Search algorithm is given here. The search algorithm, now it accepts the input here as an integer, and this is the value that we are going to search for. So P is initialized with the start, it's a local variable, and L is initially it is -1. Okay. Then we check, yes, we got the item, and we check whether the item is there in the list of P. If it is there, then we can return the location L. Okay. Otherwise, what we'll do, we will update the address of the pointer with the link of P. So that will update the P. So this operation we need to continue for the complete list. So what we do, we enclose it with the while loop, stating that continue the operation until P is equal to -1. P equal to -1 means the end of the list. So in this context, the end of the list is represented by using -1. Okay. Then, so when it comes out, then finally the last location will be returned to the calling program. So where the calling program? Here we have the line number 28, we have the calling program. So that will give the LOC. Yes, LOC may be anything. If it is equal to -1, the value returned by the search algorithm is -1, then we say that the item is not present in the list. Else, that means LOC is having some valid value, then we say that item, this particular item, presented at index location, this particular number in the list. So what are the values we are passing here? Item and the location. Item and the location values are passed here. Okay. Now let us check it out, check out the output of this program. So the same program, it's given here. Now I'm running the program. So as I run this program, you can see that first it will go through the compiling. After compilation, now As a first part, we have printed the values of the linked list. So we have given here. Now it asks for the item to be scanned. Okay. Let me say I want the item to be scanned. I want to scan for value 10, information 10. So what it will say? It will say item is not present in the list because it is not there anywhere. That we have already set up. Okay. So once again, I run this program now. As I run this program and I want to search for an item 87. Okay. So where's the item now? Yes, 0, 1, 2, 3, 4, 5, and 6. So here actually, if you start with 0, it's going to be 0, or else it depends on the program. So 87, it's basically, it is listed in 5, list of 5. So it returns the location 5. Item 87 present at index location 5 in the list. Because we can't go directly like this 0, 1, 2, 3 because something it's missing here. You can see that list 0, then it goes to list 2. So in between numbers are missing, so we cannot count here and go on. Just look at the node, what node we are using, and based on that we can check it out. Node 5, it's having the information 87. So like that we can do the searching on a linked list. Okay, thank you.